Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 10 video on the topic of determination of density of liquids from the chapter of physical quantities and measurements. In this video, I will shortly explain the concept and the related formula that we use in determining the density of any liquid using density bottle, which is also known as specific gravity bottle or pycnometer. If you find this video useful, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 10 video, where I will just briefly describe how do we determine the density of liquid using a density bottle. Okay, so I have prepared a bit of notes and the steps of how we find the density of a liquid using a density bottle. First, let's try to understand what is a density bottle. I have, as you can see in the figure, density bottle is a specially designed glass bottle which is round shaped at the bottom, and it has a narrow neck. This part, this is a narrow neck, and the primary objective of a density bottle is to store a specific volume of any liquid. Now, every density bottle has a capacity, that is the maximum volume of any liquid that it can store. Usually, the capacity comes in like 25 ml or 50 ml. Now, I will not explain how actually you fill up the so in the density bottle there are two important components. One is the glass topper and one is a hole. Now, using these two components, the density bottle is filled with a liquid whose volume will be equal to the capacity of the density bottle. Now, even if we do not know the capacity of the density bottle, still we can find its volume using some technique that we will discuss shortly. So, in brief, the primary objective of a density bottle is to store a specific amount of any liquid. So, if you completely if you completely fill the density bottle with water, and let's say it will have a volume V. Now, if you store the density bottle, if you take out all the water, dry the density bottle, and then fill the density bottle again with another liquid L, then it will be ensured that the volume of the liquid L will also be V cubic centimeter or V meter cube, whatever. So, the main objective is to, if you fill the density bottle completely with a liquid, it will have a certain volume. Now, it is not, if we know the capacity of the density bottle, then obviously the volume of the water or any liquid stored will be that capacity. But even if we don't know the capacity, using filling the density bottle with water, we can easily find the volume of the or the capacity of the density bottle. Okay. Now, I have already written down the steps, but I think just reading out the steps will be boring. I will try to interactively explain how we are using this density bottle to find the density of a certain liquid L. So, first what we do is we first measure the mass of the empty bottle. That is, we clean the density bottle and rinse it properly so that it is completely dry, and then we weight using a beam balance. My diagram will be very weird and very approximate. Let's say we are finding the mass of the empty density bottle. Let's say this is the empty density bottle, and let's say the mass comes out to be let's say capital M B, capital M with a subscript of B means MB is the mass of the empty bottle. Let's say we are using the unit of gram. Now it could be kilogram, it will not matter. Let's say this is the mass of the empty density bottle is MB gram. Okay, so this was step 1. Then what we do is we fill the density bottle completely with water. So this is water. We are filling the density bottle completely with water, and then water, and then we will measure. Then we will measure the mass of this density bottle plus the water. That is, the density bottle is completely filled with water, which means that the volume of the water is equal to the volume of the density bottle. Okay, and let's say the mass of the density bottle completely filled with water at 4 degrees centigrade. Now I think the water at 4 degrees centigrade is also known as distilled water. It is important that we are using water at 4 degrees centigrade, because we know we will use the fact that the density of water at 4 degrees centigrade we know is 1 gram per centimeter cube, or it is 10 to the power 3 kilogram per meter cube. Okay, so now let's say the mass of the density bottle completely filled with water comes out to be, let's say, MBL. BL means the mass of the bottle plus, not L, BW. BW means the mass of the bottle plus water, this much gram. Okay, so this was step 2. Now at this stage, we can clearly say that what will be the mass of the water. Mass after step 2, I can say that the mass of water which is at 4 degrees centigrade, let's say the mass of the water, we are denoting it with MW. MW will be MBW minus MB, this much gram. After step 2, we can easily say that the mass of the water at 4 degrees centigrade will be which we are denoting as MW, will be MBW minus MB. Okay, now what we do is, in the step 3, we drain out all the water. We rinse the empty bottle, dry it properly, and then fill the empty bottle with the liquid whose density we are to find. So this is the density bottle again. Let's say filled with the liquid whose density we have to find. So this is liquid L. Okay, again we will find the mass of the density bottle plus we will find the mass of the density bottle completely filled with the liquid. Okay, so let's say the mass of the density bottle completely filled with the liquid comes out to be, let's say, capital M BL. BL means bottle plus liquid, and BW means bottle plus water. So let's say this is BMBL gram. So at this stage, we can also clearly say that the mass of liquid L, let's say we denote it with ml, will be equal to M BL minus MB, this much gram. Okay. Now to find the density of the liquid, we know that the mass of the liquid whose volume is equal to the capacity of the density bottle is MBL minus MB. Now, how do we know from this fact, from these two fact, how do we find the density of the liquid? We have to know the volume of the liquid whose mass is ml, and obviously the volume of the liquid L will obviously be the capacity of the density bottle. Let's say we do not know the capacity. How do we, from these steps, how do we find the volume of the density bottle? We can find it from the mass of the water, that is mW. Why? In this case, the volume of the water will also be the volume of the volume of the density bottle, which is also equal to the volume of the liquid. Now, let's say if I say that the volume of the capacity of the density bottle, which is equal to the volume of the water, which is also equal to the volume of the liquid, let's say that volume be V. How can we find V? V we can find from MW. What is MW? MW is the mass of water at 4 degrees centigrade. This MW is MBW minus MB gram, and we know that 1 gram, the volume of 1 gram of water at 4 degrees centigrade is 1 centimeter cube. So obviously the volume, we can say V is volume of MW gram of water at 4 degrees centigrade. V is the capacity of the density bottle, and V that is also equal to the volume of the water which is completely filling the density bottle, and also V is equal to the volume of the liquid that is completely filling the density bottle. So basically the density of the liquid will be nothing but ml divided by V. So we are trying to find what will be V. So V will be volume of the MW gram of water at 4 degrees centigrade, which is nothing but MW centimeter cube, because 1 gram of water at 4 degrees centigrade has a volume of 1 centimeter cube. So using unitary method, we can say MW gram of water at 4 degrees centigrade will have MW centimeter cube of volume. Okay. So clearly the density of the liquid will be its mass ml divided by V. What is ml? ml is MBL, that is the mass of the density bottle completely filled with the liquid minus the mass of the empty density bottle divided by V was MW, that is the mass of the water, this much gram per centimeter cube, since we have assumed the masses to be in a gram. Okay. Now this is equal to MBL minus MB divided by what was MW? MW was MBW minus MB. MBW minus MB. Now I really don't want to remember this formula, even though this formula is very simple. It is nothing, we are doing nothing but we are just dividing the mass of the water, that is completely the mass of the water which is the mass of the liquid that is completely filling the density bottle divided by the mass of the water that is completely filling the density bottle. Now the catch is that the mass of the water that is completely filling the density bottle is also equal to the volume of the density bottle, which is also equal to the volume of the liquid. So that is the catch. This is why this formula will work. So if you can remember it, it is fine. I just used some different notation so that like MBL, BL means the mass of the bottle plus liquid, and BW means mass of the bottle plus water. So MBL minus MB, which is the mass of the liquid divided by the mass of the water. So you can briefly regarding the formula to find the density, you can briefly remember it this way, that all the facts will be given, that is the mass of the empty bottle will be given, the mass of the density bottle completely filled with water at 4 degrees centigrade will be given, and also the mass of the density bottle completely filled with the liquid will also be given. So you just find from this fact, you can easily find the mass of the liquid. You can also find the mass of the water. So the density of the liquid will be mass of the liquid divided by mass of water. Keeping in mind that all the masses we are considering are in gram. So this is all. This was a very short concept of using density bottle, which is also known as specific gravity bottle or pycnometer, to find the density of any liquid using a density bottle and water, and also the concept that any given mass of water in gram is equal to its volume in centimeter cube. In the next video, I will try to solve a few problems based on this concept of finding the density of a liquid using the density bottle. So please stay tuned for the next video. Once again, if this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel. And in that case, do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching. I'm ending the video here. I'll see you in the next video, and until then, take care and bye.